We are looking at these two tests together today. So you want to ask questions in the process if you don't get it, but it's quite loaded. So please have your pen and your paper with you so that you can ask as many questions as possible. All right. So let's get the ball rolling. The first thing I want us to take note of is that you can do a research in your thesis. And in the process of doing your thesis research, at some point you have to formulate hypotheses. You can have 2 samples, 3 samples, 4 samples, and then you have to formulate hypotheses. Before you can formulate a hypothesis, please note this. A hypothesis is a claim about a population parameter. A hypothesis is a claim about a population parameter. Suppose somebody with an authority makes a claim. That is a hypothesis. Okay. But there are 2 types of hypothesis. The first is a null hypothesis, and the second is an alternative hypothesis. What is the difference? Well, the null hypothesis is the authoritative statement from the person who is making it. That person is an authority. The alternative hypothesis is a mirror image of the null hypothesis. So the null hypothesis is an authoritative statement. The alternative is a mirror. Let me give you 2 examples. 1, suppose the Electoral Commission should say that NDC will win the next election, and Kwaku Bako should say that NPP will win the next election. Which of these 2 statements will shake the country? Which of these 2 statements will shake the country? I'm recording, so your answers will be given marks which are recordable. Okay, raise your hand. And when you raise your hand, you will then unmute yourself, and then you can answer your question. Which of these 2 statements, Elliot?
The one by the Electoral Commission, please.
Why?
Because that is the authoritative body that conducts the election.
Thank you. Now, suppose I make a statement that everybody will have an A in this subject, and Elliot makes a statement that everybody will fail in this subject. Which of these statements will shake all of you? Nanakuya.
Yeah, that's obvious, please.
Okay, so that's a null hypothesis, and that is alternative. The null has an authoritative statement. So keep that in mind. Now, we are going to look at 2 groups of hypotheses, 2 groups of tests. A test which is used to prove or disprove the hypothesis that I just mentioned. There are 2 kinds of tests. One is known as parametric test, and the other is known as non-parametric test. Okay, your hand is still up. What is the difference between a parametric test and a non-parametric test? A parametric test is for data that is normally distributed. Please note it down. It's for a data that is normally distributed. A non-parametric test is for a data set that is skewed. A data set that is skewed. So whenever you are looking for hypothesis testing, the first thing you want to check is whether you are dealing with a normally distributed data or a skewed data. But what do we mean by normally distributed data? All the ratio level of measurement we learned the last week, all ratio level of measurement are normally distributed. Normally distributed data is usually for numerical data type. And non-normally distributed data, like skewed data, is usually for the ordinal level of measurement. So the first thing you have to do is to check whether the data is normally distributed or is not normally distributed. Number two, you have to check. So first of all is the normality before you do the test. Second is to check whether you are dealing with the mean or you are dealing with the median. The mean represented by mu, Greek letter mu, or whether you are dealing with the median. Parametric test is for mean. Non-parametric test is for median. That's number two. The third one is to note whether you are dealing with dependent or independent sample. Dependent or independent sample. Dependent or independent sample. Please note, parametric data can have a dependent and an independent sample. A parametric data can have dependent and an independent sample, both. A non-parametric data can also have a dependent and an independent sample. What is the difference? Well, a sample is said to be dependent when the subject is repeated in each sample. A sample is said to be dependent when the subject is the same in each sample. But when the subject is separate or different, the sample is said to be independent. I'll give you two examples. Suppose I take the ages of group 1 EMBA and I check your ages. And I take the ages of group 2 EMBA and I record their ages. This sample, is it dependent or independent? You can tell me. Is it dependent or independent? There are some of the answers. I'll let you type them privately to me. Alberta.
Independent.
Why?
Because we are from two different groups, group 1 and group 2.
Good. That is correct. Now, ladies and gentlemen, suppose I take a sample where I record the profit margin of foreign banks. Okay, I record their profit margin. And I also record the profit margin of domestic banks. Is that dependent or independent sample? Is that dependent or independent sample? Raise your hand and tell me. Is that dependent or independent sample? If I take the profit margin of foreign banks, and I record all the foreign banks in the country, and I take the profit margin of all the domestic banks and I record them, is that dependent or independent? Agnes.
Sorry, sir. I'm going to take you back a bit. I missed the definition for the dependent and independent. I had issues with the network.
The
So if you
dependent
could-
sample is a sample where the subject is the same across the sample. The subject is repeated, is paired across the sample. So you are dealing with the same subject. And then independent sample is when the subject in question, the subject can be human beings, cities, or countries. Independent sample is when the subject is different. So Nana, tell us, between foreign and domestic banks, is that dependent or independent? Or your hand wasn't up?
Sorry,
Okay,
sir. My
good.
hand is up. Sorry, sir. It's dependent, sir. It was muted. Sorry, sir.
All right, so the sample is dependent sample.
Yes, sir.
That is not correct. And of course, if it is not correct, it means that it's independent. In
Yes,
this
sir.
case, foreign firms are different from domestic firms. And so whatever you record for foreign firms is completely different from whatever you record for domestic firms. The sample is still independent. Let's take another example. Suppose I record group 1. You are group 2, right? Suppose I record I do a test right now, and I record your test, okay, before the exams. And I record the test. Some had 50%, some had 80%, and all of that. And then after the exam, I decided to also record another test after. And some had 20, some had 100, some had 90, and all of that. Okay, these are two different samples. Is this sample dependent or independent? This sample, is it dependent or is it independent? Esther?
Is dependent.
Why?
Because the subjects are the same.
That's the point. The subjects are the same. So it's not about a sample, but it's about the subject. So guys, take notes. Today we are going to look at one dependent sample, which is per t-test. And we are also going to look at one independent sample, which is Mann Whitney. Okay, one of them is parametric, which means it's normally distributed. The other is non-parametric. To be able to undertake all of these tests, you have to remember, when would they be applicable in real life? Well, I just gave you two examples of Kwaku-Baako statement and electoral commission. There are several situations. When you start writing your thesis, you will have to write your hypothesis. For most of you, after writing your hypothesis, you will have to test it. And so these things that we are doing will become useful at that time. So what are the steps in hypothesis testing? I'm going to give you the steps. Please note them down. The first step is to formulate your null and the alternative hypothesis. And we are going to go through this together. Formulate your null hypothesis and your alternative hypothesis. That's step 1. We'll go through examples. Step 2 in hypothesis testing. The step 2 is to find the test statistic and the critical value. Find the test statistic and the critical value. That is step 2 in hypothesis testing. Find the test statistic and the critical value. Now, step 3. Step 3 is to find the p-value and alpha. Find the p-value and alpha. I'll explain each one of these as we go through some examples. The last step in hypothesis testing is decide and conclude. Decide and conclude statistically and practically. Decide and conclude statistically and practically. So these are the 4 steps in hypothesis. Please know them. Know them in total, because we are going to apply them in total. As we apply them, I'll be explaining each step. So we are going to look at per t-test first. When we are done and we fully get it, we'll look at Mann Whitney U test. The other ones, some of them I've done videos on them, so you can watch the videos in the process. And these two are key to me, because for your level, that's what I'm going to be, querying you about. So these are the 2 tests you want to know. It is important that you are having a pen and a paper with you, please, and a calculator with you. Okay. If you are driving, it means you are behind. So you will not have much. So you want to be able to sit down and take. Okay, let's take the Mann Whitney U test. Sorry, the paired t-test. And in order to do that, I'm going to use a particular story. So I want you to look on the screen and the story. assume you are a manager of a bank. You send some people, they are salespeople, because you have been getting a lot of complaints about this salesperson. There are 5 of them, and you decided to send them for a workshop, a customer service training workshop, because you've been getting a lot of complaints. You recorded the number of complaints for each salesperson before and after you recorded them. So for example, CB, you recorded the complaints before, which was 6. After the workshop, CB's complaint went to 4. TF, you had a complaint for TF. After the workshop, the complaint went to 6. And on, you had a complaint for MO. After the workshop, the complaint went to 0. So you recorded these complaints, and the question you want to check now is whether the training has made a difference in the number of complaints before and the number of complaints after. Let us assume that this data is normally distributed. So let me ask you, therefore, is this test a parametric test or a non-parametric test? You can tell us. Is this test parametric or non-parametric? Enoch or Enoch?
So it's a parametric test because it's you just said it was normally distributed.
Fantastic. Stay on the call. Now, tell me, is this a dependent sample or an independent sample?
So it's a dependent sample because we are still dealing with the salespeople. Like the subject is the same, so it's dependent.
Good. So are we going to deal with the mean or the median?
We're going to deal with the mean.
Perfect. Okay, so you are muted now. So those are very important, beginnings before we start. The first step now is to formulate the hypothesis. But before we formulate the hypothesis, ladies and gentlemen, you are going to do your first test. You have 60 seconds to give me the answer to this. You are going to give me the answer by privately sending me the message. So I'm about to ask you a question. You are going to privately answer me. In order to do that, you have to go to the participant and you will see my name. I'm actually the host. Then you will privately message me the answer to the question within 60 seconds. I'm recording this for a reason. Please make sure that you have me in the chat. Like when you go to the chat, okay, at the bottom of the message where you type, you will see to everyone. This time you will change it and then you will see Dr. KOA. You will rather select that one because you're about to send me. The moment you select that and you send me, you can turn it to the everyone again. Please do all follow. Last rep, somebody should say yes so that I know that you all get me.
Yes, please.
Yes, we understand.
Yes, we understand.
Please, you have 60 seconds to give me an answer to the question. Okay. May the good God be with you in this another beautiful test. Just look at the people here. You have CB, you have TF, you have MH, you have RK, you have MO. My question to you is that which person must have benefited the most from this workshop? Be careful because the first answer that came to your head might be wrong. Which person must have benefited the most from the workshop? You have 60 seconds to give me the answer. Privately. Which person must have benefited the most from the workshop? You have 40 seconds. You have 20 seconds. When it is time and it is done, I will type stop. Once I type stop to everyone, no answer will be recorded again. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Stop. Juliet Alia Agbobo, 2 patients, your answer will not be recorded. Georgette Mensah, your answer will not be recorded. Okay. All right. So I've got some lovely answers. Okay. Some of them are getting it right. Others are getting it wrong. The names of the people were here. All I wanted for you to do was to type CB, TF, MH, RK, MO for me. Okay. And the answer is TF. The answer is TF. In fact, majority of you got the answer correct. Okay. It is TF. And I've taken note of the private answers. Okay. Majority of you got it right. Now, the next question. Please pay attention. Now that we know it's TF. This is a question that is that I don't get good answers. So again, you have 60 seconds to give me the answer. I'll start the clock after I have gone through the question. So here is a question, the second question. For every 1 complaint reduction that MO will have, how many more complaint reduction will TF have? For every 1 complaint reduction that MO will have, how many more complaint reduction will TF have? You have 60 seconds to give me the answer. For every 1 complaint reduction that MO will have, how many more complaint reduction? You have only 1 answer to give. You cannot give 2 answers. You can only give 1. For every 1 complaint reduction that MO will have, how many more complaint reduction will TF have? Because you guys chose TF to be good. So for every 1 complaint reduction that MO will have, how many more complaint reduction will TF have? You have 20 seconds. 20 seconds. You know, some of the challenges when you don't know, you are wondering what else to write. Okay. 5, 4, 3, 2, 1. Stop. Daniel, Felix, Fever. The answer will not be recorded. You see, normally these answers come after a lot of deliberation. After cha-cha. You know cha-cha? Okay, so let me see those who got it. And so far, wow, some people have gotten it. That's impressive. That is very impressive. Okay. All right, so I'm going to mention the names of those who got it because there are few. But most of the time, not many people get it. So you have the first person to get it is the first person is Esther upon every Abna Ewa. The 2 of you got it excellently. Okay. Esther and upon. You have to give yourself a pat on the back. Eh? You've done very well because this is for the creme de la creme. Amanda Fiawaseme. Wonderful answer you've given me, Amanda. Louis Lawete, great answer. Emmanuel Kwashi, lovely answer. And Acrobato Patience. Patience, you have been doing well in this course, fire. Very good. Okay. Alberta Tevia, fantastic answer. So Only 5 people got the answer correct. Those of you are called, can one of you tell them the answer? Of course, I'll let you explain. And one of you tell us the answer. Those of you who were doing kitty kitty. Those of you are called. Hey, unless you didn't hear the name. If you heard your name that I called you, raise your hand. If you heard your name that I called you, please raise your hand. Okay, unless you are copying. Because you are copying, you are not able to raise your hand. Those of you I just mentioned their names, raise your hand. Otherwise, I'll cancel your marks because you have 2 marks. So you heard your names. You heard your names and you were hiding. Amanda. Okay, so the 3 of you, only the 3 of you. Okay, Amanda, tell us the answer.
So the answer is 3.5.
Explain to them how you got the 3.5.
Okay, so was by division. So for TF, the complaints reduced by 14, and for MO, the complaints reduced by 4. So I divided the 14 by the 4. Yes.
Very good. I hope the rest of you all get it. So if you don't get it, you can see it. So that is it. Eric, quick, I didn't ask you to raise your hand unless you have a question.
Yes, sir, please, I have a question.
Use the microphone.
Okay, sir, please, I have a question. Please, can you hear me?
Mm-hmm.
All right, so the answer I gave was 2.5, which is obviously wrong, but I want to find out if the rationale I had for choosing that answer is something that maybe could be considered. So I realized the difference was 14, so I did the division by 4, and I realized it was 3.5. But I thought, since you asked how many more for every single one, so I thought the difference between the 3.5 and then the one that MO would choose. That's why I put the 2.5 there. So I want to know if you say for every one reduction, how many more? Is it the difference between the TF value and then MO, or it is just the full reduction that happens for every single movement?
Yeah, so what you did, you went too much. It was just a difference, 3.5 difference. It was not, because that difference has been taken care of. What that more you were doing, it wasn't on the difference. That more was on the division that you did.
Okay.
Yes.
Okay. Okay. All right. Thank you.
Now, for you to have gotten that, you can be recorded for getting that, because it means that you have overstepped, you have over-answered, isn't it?
Yes, please.
Yes. So take if I was marking and I saw your 3.5, I would have given you that correct, and I will not check the other one.
Oh, okay. Thank you.
Yes. So you are still in the zone. I think you were the only one who did that, unless somebody else did. All right. So ladies and gentlemen, these are just preliminaries on that. Now you can lower your hand and then you can begin the real work. Okay.
So my hand is up.
Yeah, Favor.
Yes, please. So I got 14, and then I do not know. I want you to explain that place further, because I deducted 6 from the 20 and I had 14. So can you explain it further, how you got it?
So 20 minus the 6 will give you 14. That was only for TF. But I was comparing MO and TF. MO, it is 4 minus 0, which will give you 4. So now we have seen both of them, the complaint reduction. For TF, complaints are reduced by 14. For MO, complaints are reduced by 4. And my question is, how many for every one complaint reduction MO will have? So if MO reduces complaint by 1, looking at these numbers now, how many more complaints will TF have? TF will have 3.5. If this guy, MO reduces by another 1, this guy will also reduce by another 3.5. MO reduces by another 1, making 3, this guy will also reduce by 3.5. And finally, if MO reduces by another 1, this guy will also reduce by 3.5. So when you multiply these 3.5, that's what gave you the 14. And when you add, that's what gave you the 14. And when you add the 111, that's what gives you the 4 here. So for every 1 complaint reduction, this guy will reduce by 3.5. Favor, do you get it? Favor, do you get it?
Yes, please, sir. So I didn't get it.
Huh?
I'm sorry.
Okay, no problem. You watch the video, you get everything. Okay. I think you were not paying attention because when I even asked you twice whether you got it, you didn't respond. All right, so let's move on. So the next thing that I want us to do is to learn how to formulate this hypothesis. In order to formulate the hypothesis, there is a rule, there's an approach. So follow me as I guide you through the approach. Guys, if you switch off slightly with a radio, with looking somewhere, without having your pen and paper, without listening to me, with a noisy environment, without focus, without attention, you won't do great in what we're about to do today, because what we're about to do is loaded. It is usually not the best to even be using your phone for this purpose, because if somebody should call you, it will cut off the call and it makes it difficult for you to follow me. Yes, Adjoa.
Sir, please, the screen is showing the names of the participants instead of the notes.
I've just cleared the notes. I just wrote the word screen. Guys, do you see the word screen I just wrote?
Yes, we do.
Yes, no.
Not yet at my end.
So some of you don't see, it means that it is from your phone. It's from your computer. So use a proper approach to follow us through, because there are a lot of things I'll be writing here. Okay. So we are going to learn how to do formulation of the hypothesis. Okay. We're going to formulate the hypothesis. The hypothesis we are about to formulate, there are some few things you want to note. One, you want to know that this is about a mean and it is represented by mu. So we call it mu1. And this is also about a mean and is represented by mu2. These are the two samples. The hypothesis is about a mean. Whenever you are hypothesizing for two samples like we have here, all you got to do is to write mu1 and then write mu2 as well. Do it as I'm doing it, please. Mu1 and then mu2. Then you write the same thing again. Mu1 again, and then mu2 again. I am showing you how to hypothesize. Then you look through the storyline that has been given to you, and then you look for a keyword that represents one of these 6 symbols: less than, greater than, less or equal to, greater or equal to, not equal to, and then equal to. Ladies and gentlemen, there are English words we say that represent these symbols. For example, if I say the word above, which symbol here does it represent? You can tell me. If I say above, which symbol here does it represent?
Greater than.
No. It's not good when everybody is talking. It distorts focus. So you raise your hand and then you can answer for me. Valentina.
Greater than.
Okay. Now, what symbol is for not more than? Not more than. Raise your hand. What symbol is for not more than? Be careful, it's tricky. Patience.
Greater than or equal to.
Greater than or equal to is not correct. What symbol is not more than? I told you to be careful.
Less than or equal to.
Please mute yourself. Mute yourself until I call you. Okay. What symbol is not more than, Marilyn?
Less than or equal to.
All right. So the answer is less or equal to. Okay, less or equal to. Now, what symbol is not at most? Not at most. What symbol is that? Not at most. Don't deal with the not. Deal with the at most and use the not as an opposite. What symbol is not at most? Not at most. Joshua. Joshua. Yeah. Is it that I can't hear him? All right, Kofi, yes, you do.
It's greater than or equal to.
Okay, so let's see how he got it. Not at most. Okay. Let's get that. Not at most. If you try to deal with the not, you get it wrong. Deal with the at most first. What is at most, by the way? What is at most? Joshua. Favor.
Say greater than.
Okay, at most is not greater than. Favor. Sorry about that. Eric, what is at most?
Less
Maximum.
than or equal to.
Erica, do you understand? Mute yourself until you are called. Yes, Eric.
Maximum.
Sorry?
Maximum.
Maximum. No, that is not correct. What symbol is at most? Ajua?
Equal to.
Equal to is not correct. What symbol is at most? Alberta?
Less than or equal to.
Less than or equal to is wrong. What symbol is at most? Frida?
Less than.
Less than is wrong. What symbol is at
Less
most?
than.
Frida, I say is wrong. It's okay. Sandra?
Greater than or equal to.
Epoku, you think that by shouting the answer into the air, it makes you smart. I said that let me call you. There's a reason why I want to call you. You think that I cannot mention the answer to all of you? I can mention the answer to all of you, but I want you to think. I want others to get it wrong and think through. Because if you write the answer down or you say the answer, you do not help those who think they got the answer to think well. So that is why I'm deliberately asking people to answer. So don't shout your answers. Otherwise, you will be in Makalanta school. Okay. Marilyn, what symbol is at most?
Not equal to.
Not equal to is wrong. Jocelyn, what symbol is at most?
Less than or equal to.
Less than or equal to is wrong. So you see how people are getting it wrong. So you shouting the answer into the air doesn't make it right. We have to let people get it. Elizabeth, and by the way, don't translate that word into tree. Do it into tree, you won't get it. Elizabeth.
Greater than.
Elizabeth, at most.
Greater.
It's not greater than. Let me go to the next person. Sandra Mwako. See, you people are guessing. So when I say no, then you want to change your answer. Yes, Sandra.
Greater than or equal to.
So that is a thing. But the question is that how many times will somebody have said it before somebody says that? So at most is greater or equal to. That is not correct. At most is less or equal to. And the thing is that even though some of you got it correct, you change your answers also later. And so you did not know what you were dealing with. So please take note. At most is less or equal to. At least is greater or equal to. Let me go to some hands that are up. Ajiman Apia. Adams.
Sorry, you mentioned the answer, so I was going to mention less than or equal to.
Okay. Marilyn, your hand is still up. Opili Marilyn. Yes.
No.
Okay.
Otherwise now.
All right, so take note, guys. If you didn't know this, please write them down. Okay, at most is less or equal to, at least is greater or equal to. So let me ask you the question. Therefore, what symbol is not at most? Who can tell me now? What symbol is not at most? This time, the first person should get it right. Selassie.
Okay, it is greater than or equal to.
Okay. Selassie, your answer for not at most is wrong. Who can tell me what symbol is not at most? Julie, Asha.
Greater than.
Greater than. So the symbol for not at most is greater than. Guys, listen. Greater than is always the opposite of less or equal to. The opposite of less than is not greater than. Take note. The opposite of less than is not greater than. Why? If I say that she is less than 30, you can't tell me that the opposite is greater than 30. Because once you tell me the opposite is greater than 30, what you have done is that you have removed 30 from the number line. So if she is not 30, then the opposite becomes she is less or greater or equal to 30. So opposite of less than 30 is greater or equal to 30. And of course, opposite of greater than 30 is less or equal to 30. Take note of this. This is very important. So anytime you are formulating some of these hypotheses, don't look at the not. Deal with the substantive word. And then once you've dealt with the substantive word, you now can move away from that and then use the not as its opposite. At this stage, let me trick you. This is the hardest. What symbol is not below? I just want you to understand the principle of the not. What symbol is not below? First thing, you got to deal with the word and then you use the not as opposites. Patience.
Less than.
Are you sure?
Yeah.
Okay, let's analyze it and see. First thing, the below means less than. Opposite of that below is the first not. So that would be greater or equal to. Opposite of the greater or equal to is the less than. Okay, so that is for this one, less than. And finally, opposite of the not less than is greater or equal to. So the final answer is greater or equal to and not less than. You use a not to cancel the opposite or to make the opposite. So guys, watch the videos. I've done a whole chunk of things on this. Watch the video so that you can be able to go through it. This is crucial. Okay, now, what is the opposite of not equal to? What is the opposite of not equal to? I'm starting with an easy one for a reason. What is the opposite of not equal to? Alberta.
Equal to.
Okay, now keep that in mind. Now, once you have written your mu1 and mu2, and mu1 and mu2 again, you got to look through this sentence and look for a word that represents one of these symbols. Which word in this story on your screen represents one of these symbols? Who can tell me? Which word? Erica.
Difference.
Good. Erica, what symbol is difference?
Not equal to.
Good. So that's what you write first in the middle here. Not equal to. Then you will ask yourself, what is the opposite of the symbol I just wrote? And you put that down for the other one. So what is the opposite of that, Eric?
Not equal to.
Oh, sorry. The first one was not equal to. Yeah. Yeah, what's the opposite of the not equal to I've written? Lassie.
Equal to.
Is equal to.
Equal
so you
to.
write the equal to. Then you bring a colon in front of each one of them. You bring a colon in front of each one of them. Then you step back and breathe in. You step back and breathe in. Okay. Normally, I wish I don't mute you guys. I wish that you guys would mute yourself. Who is a class rep? Class rep, raise your hand for me. I want to give you a job. I want to make you a co-host so that you'll be muting people who cannot mute themselves. Okay. Do you have an assistant class rep? Where's assistant? Sayram, is Tabi. Okay, Tabi, I'm making your co-host. So please mute the people that forget to unmute themselves. All right. So once you have brought the colon in front of them, then you ask yourself this question. Please write a question down. Write this statement down. The null hypothesis always has some level of equality in it. The null hypothesis always has some level of equality in it. The null always has some level of equality in it. Now that you've written that sentence, which of these two hypotheses I have written here is the null hypothesis? Is it the top one or the down one? Unique.
The down one.
Perfect. Once you know it's a down one, give it the H naught. And the top one, give it the HA. That is how you formulate hypothesis. So how do you formulate hypothesis? Let me just repeat quickly. First thing, write your mu1 and then your mu2 because there are two samples. Write your mu1 and your mu2 again. Okay. Then look for the symbol that represents the word, the important word. And the important word, you got to look for it. In this case, is difference. You ask yourself, what symbol is difference? And the symbol is not equal to. Write it down. Ask yourself, what is the opposite of that? The opposite of that is equal to. Write it down. Bring a colon in front of each one of them. Ask yourself, which of these two has some level of equality in it? The down one. Therefore, the down one is a null hypothesis. And the top one is an alternative hypothesis. You have formulated your hypothesis. This is statistics that you just did. But what is the English meaning of what you just did? What does a null hypothesis mean in English? Who can tell me the meaning? Because you have to document the meaning of the null hypothesis you just wrote. Who can tell me the meaning? What does it mean? H naught column mu1 equal to mu2. What does it mean? What does a null hypothesis mean? In terms of the workshop, training, customer complaint, before and after, all of that, what does it mean? What is the meaning? What does it entail? Sayram. Innocent.
Doctor, I think it means that the training did not make any difference in the number of complaints received.
That's good. That's good. I'll buy that. I'll buy that. So one way somebody will explain this is that there is no difference in the number of complaints before and the number of complaints after the workshop. There is no difference in the number of complaints before and the number of complaints after. In short, that's a better one you said. Okay? The workshop, the training workshop was bogus. That's what it means. Because if the workshop didn't make any difference, then the workshop was useless. Yes, Julie. Julie, your hand is up.
Sorry, I had unmuted. Okay. So if I'm to get you right, it says that has the training made a difference? But you said we should look for a symbol that indicates a difference, right? And less than is a difference. Greater than is a difference. And greater than is also a difference.
Less than
So
is
why
not
are we?
difference.
Hello?
I said less than is not a difference.
It's not a difference. Oh, okay.
Okay.
All right.
If I tell you, for example, let me just give you a clue. If I tell you that there is a difference between A and B, what symbol will you use for that? And I'm talking about mathematical symbols. And remember, I gave you 6 of them. I didn't say A is less than B. I didn't say A is smaller than B. I didn't say A is bigger than B. I said there is a difference between A and B. The symbol you will use is A not equal to B. Is that not what you look?
All right, thank you.
Okay, let's go to the next hand. Nanakuya.
Please, I've lowered it. I thought you were asking a question. That's why I raised my hand.
Okay, so now that you have formulated a hypothesis, we go to step 2. Who can remind us of step 2? You can remind us of step 2. Yeah, I'm sure you all wrote it down. Jacqueline.
So you find the test statistic and the critical value.
Jolly good.
Jolly
Yeah,
good.
if you are here and you have not spoken, you should not leave here without speaking, because it will not count as your class participation. Take note. Okay, we are documenting everything anybody says, so take note. Okay. All right, so let's go and find the please, this null and alternative hypothesis and the meaning, note it down. One more thing before we clear this null and alternative hypothesis. The symbols I gave you, the less than, the greater than, the less or equal to, the greater or equal to, the not equal to, and the equal to. These symbols, 4 of them are one tail, 2 of them are two tail. Who can tell me which 4 are the one tail and which 2 are the two tail? You can just tell me which 2 are the two tail, and I will know that we'll all assume the other 4 are the. Which 2 are the two tail? Valentina.
Not equal to and equal to.
Okay, so ladies and gentlemen, anytime you formulate your hypothesis, you have to tell us, you have to write the tail. And the tail, whenever you see these 2 at the bottom here, they always represent two tail. And then the others represent one tail. What is the meaning? The meaning is that it is important to know which tail you are dealing with, because we will use that in hypothesis. Now, what does that tail mean? Suppose you are dealing with the not equal to. What it means is that the direction are 2. Okay, the direction is 2. For example, if you say that she is not equal to 30 years, you are actually saying that she can either be above 30 years or below 30 years. So the direction is 2. That's why it's 2 tail. But if you say that she is less than 30 years, it means that she can never be above 30 years. So the direction is 1. So take note. So for this purpose, our tail we are using for this is 2 tail. Note it down. Okay. At this stage, we are ready to go to step 2. And step 2 says that find the test statistic. This is a formula for the test statistic. Look at it with your eye. This is the formula for the test statistic. This formula is deep. Because the one down here, which is the standard deviation, to get that, you need to go and use this formula. Ladies and gentlemen, please write the formula down in your book. It is one way to remember it. Please write it down. It's one way to remember it. So how do you find the test statistic? You need to generate a table. And the table should be made up of 3 columns. The first table we are going to generate is known as D. The second is D minus D bar. The third is D minus D bar all squared. Welcome to master's degree. So how do you find D? What is D? D means difference. That D is what you find here in this part of the formula. That is a D. It means difference. What does that mean? It means that you have to find the difference between the before and then the after for each number. You find the difference between the before and the after for each person. Let's start. For CB, what is the D? Who can tell us? I'm about to let you do a quick test again. What is the difference for the D for CB? Sarah. What is the difference for the B? Ali. Ali. Ali.
Yes, sir.
Yes, sir.
Yeah, the difference is 2.
Yeah, the difference is 2. The difference is 2. Okay, so you have a difference of 2. Ladies and gentlemen, what I want you to do is that I want all of you to find the difference. And after finding the difference, sum them and tell me the average of the difference. After finding the difference, sum all of them and privately message me the average of the difference. I'm going to give 20 marks to the first 10 people who truthfully will message me the average of the difference privately. Truthfully message me the average of the difference after you have found it. The first person has sent me an answer. Felix, that is wrong, but you have only one chance, so you can't bring another answer. Valentina, that is correct. Rule, that is correct. Sairam, Georgette, Betty, Unique, okay. Bridget. I need one last one. Jennifer is wrong. Louise, finished. Finished. Don't send again. So, oh God. The difference is supposed to be 4.2. 4.2. I told you to have a calculator with you when we started, and I know you are using it a lot. Okay. Now, how did you get a difference? Well, it's simple. The second one was 20 minus 6, which was 14. The third was 3 minus 2, which was 1. The next was 0 minus 0, which was 0. The last was 4 minus 0, which was 4. The next thing we are going to do is that we're going to take each difference and subtract the mean, which is a difference bar, the D bar, from it. So what it means is that you have to take the first one, 2 minus a 4.2, you put the answer down. 14 minus a 4.2, you put the answer down. Let's work it all together. What is 2 minus 4.2? Elliot.
It's minus 2.2.
Minus 2.2. What is 14 minus 4.2? Ali. Ali. Agnes.
So it's 9.8.
9.8. What is 1 minus 4.2? Abigail. Ali Matu.
Sir,
said negative
3.2, sir.
Negative 3.2.
Why did it take you forever?
So I was trying to unmute myself.
Guys, don't worry. Try and unmute yourself, mute yourself, and do. You know me, I'm writing, I'm checking, I'm looking, I'm identifying all of you. You got to be doing all of these things at the same time. Normally, when you are doing these things on your phone, that's where the problem is. You got to do it on your laptop. You got to pay more attention to me than your husband or wife at this time, at this moment. I am the most important person to you at this short time. So give me all your attention. All right. The next one is negative 4.2. And the last one, who can tell me the last one? Negative
0.2.
0.2. All right, so we are done. What I want you now to do is, I want you to add all these, square them. Take each one of these numbers and square them on the right. So you take the first one, you square it on the right. You take the next one, you square it. When you finish, add all of the sum of the squares. And then the answer, privately send me the answer. Okay, so first take the square of each number on the right here, and then sum them. When you sum them, you get a certain number in this equal to. Privately send me the answer. I just need the first thing. Truthfully, work it out. Richmond, first person, 9 more to go. Richmond, your answer is correct. Stephen, correct. 8 more to go. Bridget, correct. 7 more to go. Patient, 0. Eunice, wrong. Eric, Kwete, wrong. Valentina and Joshua, correct. Michael, wrong. Amma, correct. Jennifer, correct. Louis, correct. Stop. Okay. So that's it. Those are the correct ones. Very good. Very good. Very good. We just put that down here. So when you do it correctly, you're going to get to this answer, which is 128.8. When you do all and you get this value, you get the value, you get this value, you're going to get 128.8. That is how you work it. Okay. Now, this means that if you take your calculator and go through, you're going to get it. Ladies and gentlemen, that will give you the numerator of this. That will give you the value here, what you just did. So what I'm circling here is a 128.8. So you have to now find the standard deviation, which is this SD. And that will be equal to the 128 divided by n minus 1. What is n? You can raise your hand and tell me the value of n. Alimat. Salasi.
N is 5.
N is 5, correct. So you have 5 minus 5. Okay, so I want you to substitute and find me after you've taken the square root. Okay, you've taken the square root. Then, listen, once you have found that value, come and drop it here. Come and drop it here, because that will be the same value. And then divide that answer by the square root of n. We already know that n is 5. So just drop it here and divide it by the square root of n. And then take the mean. The mean we know is 4.2. And divide the mean by that answer you got down here. And then tell me your value of the t statistic. privately. When you have gone through that, that will give you the T statistic when you've gone through this. You tell me the value of the T statistic. Innocent, your hand is up. Why? Papa Innocent. Okay, so when you're done with the right answer, you type me the answer. Again, the first 10 people. Amma, unmute yourself and let me ask you a question. Amma.
Hello, Doc.
What was the value of your standard deviation?
So the value of my standard deviation was, I think I placed all together and I computed it. I have to. 2.53. So I had 2.24 and then 2.53. So I divided 2.24 by the 2.53, then the square root of the 5.
All right, that's fine. Okay, so the first person to get it right is Amma. Richmond, the answer is not correct. Check it again. Bridget, that's fine. It's correct. So I've got 2 people. I will need 8 more people. Valentina, that was not correct. Ali, that is not correct. Remember, you are finding the T statistic. I still need 8 more people. Georgette, that is correct. Good answer. Elliot, that is correct. Good answer. 6 more to go. Patience, come again. Jennifer, come again. I still need 6 more people. Bell, give me your full name. Write your full name, rename yourself so that I can document it. Okay, that is correct. Marilyn, that is correct. Valentina and Louise, that's wrong. Come again. I need 4 more. Julie Asher, Felix Gipo, that is correct. 2 more. Eunice, that's wrong. Ajua, that's wrong. Agnes Asante, correct. Eric Kwete, correct. That's all, finally. Okay, so some are really doing well, man. Some are really here. Some were born to be here. Some were born and battered and breaded in this room. They were foreordained to be in this room. And I love that. So when you do all this, you are going to get 1.66. That is your test statistic. This one is calculated. That's all help you. When you look at step 2, you have to find this test statistic as well as the critical value. We just found a test statistic. How about a critical value? Let's do that. Ladies and gentlemen, there is a formula. Oh, by the way, the critical value is also called the tabulated. We are going to find it from the table. The critical value, yes, Michael. Michael, your hand is up. Michael Ajatu, your hand is up.
Can you hear me, sir?
Uh-huh.
So we are sorry. Some of us we joined very late. You know, our schedules are so tight to the extent that we can't actually probably.
You don't have to say this because we all know the time we have to start, isn't it?
Yes, I know, but then that's why I'm craving your indulgence. That should pardon us. Most of us are lost. It's just for the fact that some of them can even say it. No, but I'm speaking on behalf of the masses. They can't talk, but
But
they are bleeding.
When
the
bleeding,
sir.
Massa, stop this, I'm pleading. We are not in a Imakalanta. When the masses is lost, you can ask a question. That is the definition of lost. So I don't really endorse online teaching. I don't endorse it at all because it doesn't make people participatory. Now, if you were physically present with me in a class, physically, you would have been watching your colleague, and then you'll be looking at his answer and asking your colleague how it went and all of that, and you would have followed. But right now, you are in the confines of your own room or home. And so that is where you are lost, okay? So it means that you will not be able to get the energy that you would have normally gotten from your colleagues. Even if you were lost, if you were by your colleagues right now in the classroom, you would have gotten the thing some way, somehow. So, and again, it's also not because you joined late, because for some, they will not get it. Whichever way you slow down or you repeat it, they will not get it immediately. For some, they will still need to go home, go through the videos and work it all again, okay? But at least for areas where you don't understand, you can ask. That's what you can do. You can ask that, I don't get this part, explain it for me. I don't get, for example, if you didn't get a 128, it doesn't mean you are lost. The reason why you couldn't get a 128 is not because you can't get it, it's because you could not type your calculator fast. You cannot use your calculator faster to be able to get the answer faster, like your colleagues have gotten the answer faster and mentioning it. But it doesn't mean that you cannot do it. So when they give the answer, and I repeat the answer, yours is to just write the answer down and move on. And write the answer down and move on, okay? But if you want to ask a question about how they got it because you cannot work it, you can also ask about that, okay? Yes, Eunice.
Yes, sir, please, can you assist with the computation for T?
T?
Yes, please, the 1.66. I'm not too clear on how it was. Yeah.
So what your colleagues did is that, you see now she's asking the question. What your colleagues did is that they took this formula, which was the D bar. We found it down here. Okay. So they took that value, which was 4.2. And then they divided the 4.2 by the standard deviation here. Okay. Now, I told you guys to find that standard deviation. When you all found the standard deviation, what did you get? Is it 5.67? What did you get?
5.67. Yes, 5.67.
Good. So they got that 5.67. So you come and put the 5.67 here. And then do your square root, the square root of n. Okay, n is 5, so you put in 5. At this stage, it's just your calculator. So you tell your calculator 4.2 divided by bracket 5.67, okay, divided by the square root of 5. And your calculator will give you that 1.66. Eunice, do you get it?
Yes, sir. Yes, sir. Thank you.
All right. So now that you've gotten the test statistic, which is this T, the next thing is to find the critical value. Ladies and gentlemen, this is how you find the critical value. The critical value is given by T subscript alpha, comma, n minus 1. Write it down, please. Write it down. Write it down. You know, when somebody didn't understand how we got the T statistic, so the person will not even write the critical value down. Okay, I'm sorry. Okay, for this, you have to write it down. Okay, you either drink deep or it tastes not, the Pierian spring. Their shallow drought will intoxicate your brain, and drinking largely, not smallly, largely, will sober you again. So you just write whatever down. Okay, you will get it, and if you don't get it, you can ask. Okay, so now is the time I'm going to explain the alpha and then the p-value. If you remember step 3, go to your book and check your step 3. Your step 3 says And by the way, everything I'm saying is in the slides and it's also in the video. Your step 3 says that find the p-value and alpha. Now I'm about to explain the alpha to you. Alpha is the expected error you make in a research. Is expected error, the expected mistake that you can make whenever you are doing a research. Let me give you an example. I told you the story of the Kwaku Baku making a statement and the Electoral Commission making a statement. And in that statement, we realize that because the Electoral Commission is the authority, the Electoral Commission doesn't need to prove anybody. It's Kwaku Baku who got to prove us whether the MPP will win or not. He has to prove. So the onus lies on Kwaku Baku to prove the nation whether truly the MPP will win. So normally Kwaku Baku will gather information, evidence. And in the process of gathering all of this, he will make some mistakes. He will make some mistakes. Of course, he's allowed to make some modicum of mistakes. He's allowed, he's expected to make some mistakes. The mistake you are expected to make in research is the alpha, the level of significance. It's also called the level of significance. The mistake you are expected to make is an alpha, also called the level of significance. There are only 3 of these mistakes you are allowed to make. The first is 1% mistake. The second is 5% mistake. And the third is 10% mistake. These are the 3 mistakes you are expected to make in a research. If there is an expected mistake or an expected error, then there must also be another error. Who can tell me that error? If there is, and those who do accounting will know, there is an expected error, then there is also what error? Who can tell me? Eunice.
Sorry, sir, I forgot to lower my hand.
Okay, Valentina.
Unexpected.
Hey, yeah. Those opposite things for us. Okay, who can tell us? Oh, there was another hand that was up. If there is an expected mistake or expected error, then there must also be what error? Come on. Come on, accounting. Okay, you do that, Arabia.
Sir, mine is a question. I wanted to ask, is the expected error same as the margin of error?
No, it's not the same. Because if I should ask you truly what is the margin of error, you yourself, you'll be confused about exactly what it is. Okay. But it's not the same. And I want to explain that here because you get you guys confused because I'm teaching practical. I'm not teaching just statistics. The expected error is the mistake you are allowed to make in the research, and there are 3 of them: 1, 5, and 10. What is the other mistake or error? What is the other? Some of you raise a hand, you've all lowered your hand. I have not explained though the other error. I say you should tell me. Favor.
I'm not really sure, but error of omission and error of commission is also there.
The other error is what?
Error of omission.
Error of what?
Omission.
But you can't error of what is the error? What is
error of omission and error of commission. It's like
thank you for your wrong terminology. Yes, Alima too.
It's a transpositional error.
Transpositional. I love that. I don't even understand that one. Yes, Favor. I can imagine somebody Googling it. You don't get it in any way.
No, I was trying to lower it.
Okay.
Thank you.
Yes, Valentina, your hand is still up.
Yes, I want to try absolute error.
Okay, so the error is known as actual error. So if there is an expected error, there is also actual error. The error you actually make is different from the error you are expected to make. Now, the actual error is the p-value. So please note the p-value is the error you actually make. Okay. The error you actually make. Now, let me ask you guys something. Which of them would you wish it is smaller? Is it the p-value or the alpha? Which one would you wish it is smaller? Is it the p-value or the alpha? And of course, I'll ask you your reason. Yes, Agnes.
So the p-value.
Why?
It's always best to have little errors in your research. And so I would rather have that.
Okay, you have not explained it well for me. Eric. Is it the actual or the expected error?
All right, so the actual error, we shouldn't make any, we should try as much as possible not to have a very large portion of that.
Why? Why should that be small?
Because that would be an unacceptable, I mean, to fall in an unacceptable range. So if you get the actual error wrong, then the unexpected probably may have been, it means the unexpected may have been covered and then we have moved into the range of the expected.
Why are you confusing me? Make life simple for us now. Make it simple. Oh. I don't know why you guys have started using unexpected. I'm trying to make it complex. Sayram, tell them the answer.
So the actual error, I think the actual error should be lesser than the expected error so that the credibility of your research is still held up high.
Okay, so the basic thing is that the actual error is an error you make. That is an error you make. That is an error we know you made. That's why it should be smaller. The expected error is not an error you make. It's an error that has been imposed on you not to go above. You know, I said that it's expected error. And I even told you that there are only 3 of them. So you have been told that error, that you should not go above 1%, you should not go above 5%, you should not go above 10%. So it's an impositional error. It's an error you have been, told not to go above. That is not an error you make. And so if you are doing the error, if you are doing the research, you are going to commit that actual error and not the expected error. And so you will want the actual error to be smaller so that you can have enough confidence in your research. Note that down. So that you can have enough confidence in your research. That part here is an exam question. Okay. So you need to be able to make a smaller actual or p-value so that you can have enough gravitas to reject the null hypothesis. You can have enough confidence to reject the null hypothesis. All right. So take note of the difference between p-value and alpha. Okay, so now let's go and find our critical value. The formula is here. It says that know the value of the alpha. Ladies and gentlemen, I told you that the alpha is only 3. If in a question, you don't know what the alpha was, or you have not been given the alpha, the default is always 5%. So please note that down somewhere. The default alpha is always 5%. So now let's write our T, our critical value. It is going to be T subscript, what value? T subscript, what value? 0.05, yes, 0.05, comma, n minus 1. What is n minus 1? Who can tell us? What is n minus 1? So, Asante, unmute yourself. What is n minus 1?
It's 5 minus 1.
Which is?
4.
Okay. What does n minus 1? That's correct. What does n minus 1 mean? N minus 1 means degrees of freedom. Degrees of freedom. Okay, that is a n minus 1. And I told you that a critical value, you always find it from the table. So we are about to go to the table. So when we go to the table, we are going to read the value of 0.05 against 4. The 0.05 against 4. That's what we are going to do. Okay. So if you are ready, yes, Sandra, your hand is up.
Sir, please, I didn't get what you mentioned. The n means what? You mentioned something. I didn't get it.
N is the sample size, and n minus 1 is the degrees of freedom. N minus 1 is the degrees of freedom.
Degrees of freedom. Okay. Thank
and we
you,
are going to check that degrees of freedom against the alpha value of 0.05 from the table right now. We are going to do that. So let's go and check. So you go to the table. All of you, please take your table. Don't even use mine. Use your own. Okay. And this is mine, but use your own. The T table. That's a T table. At the top of the table, you have the alpha. Okay, you have the alphas. They are here at the top of the table here. The alpha. That is the T table at the top here. We have the alphas at the top here. Those are them. And then on the far left, you have the degrees of freedom. On the far left column, we have the degrees of freedom. You will see DF written at the top left. What you are going to do is that you are going to match the degrees of freedom we selected. Who can remember the degrees of freedom we selected? What was the value of our degrees of freedom? What was the value of our degrees of freedom? Bridget. Yeah, Bridget.
4.
Okay, so that's 4.
4.
Now we go to the alpha level. Do you remember which tail we are dealing with? Early on, I told you the tail. Were you dealing with one tail or two tail? You can remind us. Yeah, Bridget. Alberta.
2 tail.
2 tail.
Good. So now I want you to match the 2 tail 0.05. You don't have to divide by 2 because the table has already done it. So take 2 tail 0.05, match it against 4, and privately send me your answer. Take the 2 tail, match it against 4, and send me your answer. Let me see. Remember, where they meet, you are taking it. Okay. Here you have 1. You have 1, you have 2, you have 3, you have 4. You are going to match that against the T, the 0.05. This is a 0.05. So where they will meet, the number there, okay. The majority of you are getting it correct. If you haven't typed some, type some more. Okay. Type some. Where they will meet, that's the number I'm looking for. Type some. Lasisi, your answer is not correct. All of you are getting it right, but some are not getting it right. So far, Lasisi, you're the only one who has gotten it wrong. So if you check it, it should be 2.776. That's the answer. 2.776. So please note that your test statistic is 1.66. And your critical value, which we call T critical, is 2.776. Write it down. In an exam, if somebody should write 2.776, I know that it took the person a lot of effort to get it. So that is step 2. Step 2 is done. Let's go to step 3, unless you have a question. Yes, Julie.
Yes, please. Thank you. I understand we've done the t-test and then the critical value, but what is the interpretation of like 1.6? What does it mean? And then 2.776, what does it mean?
Okay, that is actually step 4. That is actually step 4, the final step. So when we get there, we'll interpret all of them for you.
All right, sure. Thank you.
Now, let's go to step 3. Okay, the step 3. Who can remind us of step 3? Who can remind us of step 3? You all wrote it down. Who can remind us of step 3? Betty.
Prof, please find the p-value and alpha.
Thank you. Find the p-value and alpha. And for those of you who didn't come early, that is what you should write down as your step 3. Find the p-value and alpha. Okay. We now know what the p-value is. We know the p-value is the actual error you make in your research. You make. But then the alpha is the expected error, the one that is imposed on you. It's kind of a benchmark error. As for the alpha, we know the value already here, so we don't need to find it. So who can tell us the value of the alpha? So that we don't even bother ourselves finding that one because we know it already. What's the value? Ajaman.
5%.
Very good. Let's put that one down, 5%. What we need to do is to find the actual, the p-value. Now write this down. Always use the test statistic to find the p-value. Always use the test statistic to find a p-value. Always use the test statistic to find the p-value. Always use a test statistic to find the p-value. Who can remind us of the value of the test statistic? Who can remind us of the value of the test statistic? Erica.
1.66.
Good. Let's write that down here. Okay, so test statistic is 1.66. The question is, how do you use it to find the p-value? Well, this is what you do. You go to the T table, and then you dump the 1.66 boom into the swimming pool of the table. You dump it boom into the swimming pool of the table. This is the swimming pool of the table, the entire table. You dump it boom into the swimming pool of the table, and you look for the number or the numbers closest. You look for the number or the numbers closest to 1.66. The number or the numbers closest to 1.66. Who can tell us those numbers? I'm making the table big for you. Who can tell us the number or the numbers closest to 1.66? Georgette. Yes, Georgette. Okay, Eric.
1.638.
1.638 is not correct. Okay.
Hello, there's 1.66.
Huh?
There's 1.66.
No, it's not exactly that number. There's not exactly 1.66. I want exactly a number or two numbers closest to 1.66. Elizabeth.
1.533.
No, that is not correct number we are looking for. Let's go to Innocent.
Doc, please, I see 1.660.
The
And
way
I
you sound,
also
it
see,
looks like you have another one to say.
no, so I see 1.660.
So that is correct. So Jajet, the answer I was looking for was not 1.66. I was looking for 1.660. But there's also another number closest. Which other number? Amma. There is also another number. Unique.
1.664.
That is it. So ladies and gentlemen, those of you who are following me, the number you are getting is supposed to be these two numbers, one of them. And they must always be on top of each other. 1.664, 1.660. Once you find them, they are not your p-values, so they are only going to guide you to get your p-values. So how do they guide you? You climb up. Once you find a number, start climbing up. Start climbing up. Start climbing up until you get to the very top. And you pick the two-tail, because we are dealing with two-tail. You pick the two-tail p-value. You pick the two-tail p-value. Therefore, we can say that our p-value is what? You can tell us. Baba Odum, our p-value is what?
0.10.
0.10.
0.10.
Perfect. That's it. So, ladies and gentlemen, our p-value is equal to 10%. Our p-value is equal to 10%. Okay, so you always have to use the test statistic to get a p-value. Lovely. Now, question. At this stage, let's try to have the meaning of these numbers. The test statistic, which is a 1.66, that was the, please lower your hand if you don't have a question. And ask your question if your hand is up.
No, there's a question. Unfortunately, I don't know how she got the 0 points, the figure she gave. If you can help, please.
Okay. So when you look at the table, and I want to believe that you all have your table. Ajiman, do you have your table?
Yes, I do.
So you look for, we said that, I told you to write a sentence down. I said that use the T statistic to find the p-value. Do you remember?
Yes, I do. I actually got up to where we got the two figures, the 1.660.
Okay. Once you get the two figures, all you got to do is to climb up, vertically up, until you hit the black p-values. Where one is one tail, one is two tail, the probability values. So you keep climbing up from those numbers you got. Just climb up vertically upward until you get to the probability values. And then you select the two-tail one, if you are dealing with two-tail. If you are dealing with a one-tail, you select the one-tail value.
Okay, I've seen it.
Okay.
Okay.
So that is how we got our value. What does the test statistic of 1.66 mean? It is just the information that Kwaku Bako gathered. That is just the information Kwaku Bako gathered. What about the critical value? The critical value is the information Kwaku Bako should gather. The critical value is the information to gather. You are expected to gather that information. But the test statistic is the actual information you gathered. I think one lady was asking us, what do they mean? Okay. So that is it. Now, what about the p-value? The p-value is the actual error you made. Alpha is the error you are expected to make. Alpha is the error you are expected to make. p-value is the actual error. Now let's go to step 4, the final step. Who can remind us?
Question.
Yes.
So please, I wanted to find out why it was changed to percentage. I saw 0.10.
Oh, okay. Well, to be honest, my dear, the number 0.05 is the same as 5%. And the number 0.01 is the same as 10%. Yeah. It's the same. One is decimals, one is a percentage. What is 100%? Do you know 100% is the same as 1?
Yes, sir.
Yes. Okay.
Yeah. So therefore, 90% I can make it 0.9.
Okay.
80% I can make it 0.8. It's the same thing. All right. Who can remind us of step 4? Yeah, somebody has a question. Go ahead. Step 4, Betty.
Yes, Prof. So decide and conclude statistically and practically.
Okay, so let's first go to decide before we come to conclude. Ladies and gentlemen, decide means that you need to have a decision rule. So let me give you the decision rule. Okay, I'm about to give you the decision rule. There is just a rule that you should have in mind. Here is a rule. Reject the null hypothesis if the calculated is greater or equal to the tabulated. Reject the null hypothesis if the calculated is greater or equal to the tabulated. And then the second one, if the p-value is less or equal to alpha. If the p-value is less or equal to alpha. This is the rule. By the way, the calculated is a test statistic, and the tabulated is the critical value. So, ladies and gentlemen, using this rule, who can decide for us? Should we reject our hypothesis or we should not reject our hypothesis using this decision rule? Who can tell us? Should we reject our hypothesis or we shouldn't? Should we or we shouldn't? Yes, Erica.
So we shouldn't reject it.
Why?
Because the p-value which is 10% using the second rule. The second rule was that we have to reject it if
don't
it's
pick
less
one of them.
than or equal to, but then what we got is greater. And for the first one, the calculated value we got to that was 10%. So okay. So please let me come back.
Good. Thank you for telling me you want to come back. Bridget.
Okay, Prof, please, using the first rule, the test statistic is less than the
Mention the numbers.
one.
Anytime you're talking, mention the numbers too.
Okay, so 1.660 or 1.66 is less than 2.776 for the first two. So we shouldn't reject it. And then with the second rule, the p-value, which is 0.10, is greater than the alpha, which is 0.05. So we shouldn't reject null hypothesis.
Excellent. You want a question? You get it.
Yes, I also have a little question.
Right.
The two rules, should they both apply before we reject or only one?
Both.
Pardon?
Both should apply. Both should lead to the same conclusion, so both must apply.
Okay.
Now, yes, Eric.
Please, I'm taking us back for just a second. So, with the decision rule, we are looking at the test statistics and critical value, and then the P and then alpha.
Right.
Which of them is greater than which of them each other?
Yes.
Thank you.
Are you clear? All right. So based on, so this is how I would have decided. I would have said that since the test statistic of 1.66 is not greater than the critical value of 2.776. You see, I'm using the numbers. And the p-value of 10% is not less than the alpha value of 5%, we reject the null hypothesis at the 5% level of significance. That's the decision. We reject the null hypothesis at the 5% level of significance. That last statement must come because this is a 7 mark, so you got to really write it well. We reject the null hypothesis at the 5% level of significance. Now we go to the conclusion.
Sorry, sir, I can't hear you well. Are you saying we will reject or we won't reject?
Oh, sorry, we don't reject the null hypothesis. We don't reject the null hypothesis at the 5% level of significance. Bridget, do you have a question?
No, sorry.
Class rep, you people are not doing your work at all. Okay, so what will be the conclusion? What will be the conclusion given what we've decided? How do we now conclude in terms of the training workshop, complaint before and after? What is going to be our final conclusion? Who can conclude for us? Jacqueline.
Okay, so I wanted to ask a question. The decision for what we just did, could you take it again, please?
Since the test statistic of 1.66 is not greater than the critical value of 2.776, and the p-value of 10% is also not less than the alpha of 5%, we reject the null hypothesis at a 5% level of significance.
We don't reject.
Sorry, we don't reject the null hypothesis at a 5% level of significance. And conclude that, let me do the conclusion for you. And conclude that the workshop is bogus. And conclude that a training workshop is bogus. Guys, that conclusion didn't come automatically. It came because we rejected the null hypothesis. So that means that you must know what your null hypothesis, sorry, we didn't reject the null hypothesis. It came because we didn't reject the null hypothesis. And you got to know what that null hypothesis said. So if you go back to your note, you will notice that then the meaning of the null hypothesis was that the workshop was useless. And we didn't reject that. We didn't reject that. We didn't reject that. So we are confirming that truly the workshop was useless. So you got to always know your null hypothesis, what it truly means. If you don't know what it truly means, you will not conclude well. Decision rule is 5% mark in an exam. And conclusion is also 5%. Erica.
Sir, please, I wanted to know if we can use synonyms to the bogus that you said.
Useless.
Okay.
Unnecessary.
Thank you.
The workshop was unnecessary. But I think bogus is not the right word. Sure. If we
No, I'm just asking. I just want to be sure.
It sounds very, very, bush talk. Eh? It's proper grammar. Yeah. It's proper grammar. You have to drink some water, you'll understand. Yes, Sayram.
Hello, Doc. I'm a bit lost at the conclusion because I think our null hypothesis was the workshop was bogus.
Yes, and
so if we are rejecting it.
We didn't reject that.
We didn't reject it, so it means it was actually bogus.
Truly, yes.
Oh, okay. Okay. So, thank you.
Ladies and gentlemen, let me ask you a question. This one is thinking cap, and I do this also all the time in an exam situation. If you look at it from hindsight, by the way, there are 4 sides to the human eye. There are 4 sides to the human eye, just as there are 4 mental sides to the human brain. The first sight is hindsight. The second is insight. The third is foresight. And the last is oversight. What I'm about to tell you is the first sight. From hindsight, it looks like the training workshop was good. Will you all agree with me?
Yeah.
However,
yes.
Our conclusion looks like it was not good. Why? Why? Who can tell me why? The last time somebody was able to give me the correct answer to this was 2014. Who can break the record? Eric, quickly.
Okay, sir. So I think the reason would be maybe the level of the expected level of error that was used for the analysis. So maybe the training took place, there may have been some difference in the number of complaints, but is it up to the target to set? I feel maybe from the analysis, it looks as if the level of error that was expected was exceeded. So there was some actual error. And for that matter, we didn't really meet, we don't have the gravitas to reject the null hypothesis.
Oh, really? Oh, dear me. I like the pump and the page entry with which you answer. That was a nice try. That's wrong. Let's go to the next person. When I said I was wrong, then Valentina raised the hand again. Yes, Valentina. I'm giving.
I want to try.
I'm giving 3 marks for this, so no joke. Yes, Valentina.
Doug, just glancing through the data, I was looking at it from the point of view that after the training, at least non-complaint reduced by, let's say, half of the total complaints before the training. That's what I see. I don't know if I'm right or not.
Have you finished? You are answering for Max. Don't say if you are right or wrong.
I'll finish, Doc.
Okay, thank you very much. That is all correct. Let's go to Darko Boati. Darko, something tells me you are going to crack the answer. The energy in which you have raised your hand. This is the first time you are raising your hand, isn't it?
Yes.
Okay.
But
Don't disappoint me.
Okay, so I think when you look at the data, it's like TF is actually having the junk of the data, which is making the data, I don't know how to say it, but when you look at the data, TF, he mostly benefited for it, and his the data is too much for you to classify the training as a good one. So that is what I think.
Are you finished?
Yes, please.
Wonderful. That is wrong. Richmond, Amponsa.
Yeah, Doc.
Go ahead.
Okay. So I think from one of your lectures and research also made known that the best sample size that might give you confidence in your data is a minimum of 30. That's what I could say for now.
Oh, you haven't spoken.
So okay, so okay, yeah. So taking our sample here into consideration, which is only 5, it doesn't give us confidence in the statistics that we derived or the decision we are making.
Okay. So when you started talking, you said that from my previous lecture, is that what you said?
Yes, please.
You mean my previous lecture with you last week, or from my lecture video?
Your lecture video, please.
Very good. So that is 3 marks for you. That's the right answer. At least it shows that you watch my videos. Richmond, you are rich. You are rich with knowledge. It's called Apo, isn't it? Yes, please, ladies and gentlemen, give him a big round of applause. He's the kind of person you should befriend, not the ones you befriend. You know, he's the one you should befriend.
Hey, Doc.
People like that are rare gems. They are in a utopian economy. Hard to find. His mental gymnastics is very highly masturbated. That's very wonderful. Patience, you have a question?
Doc, please let him come again. I didn't get the answer he gave.
Okay, so what he's saying is that the reason why it looks like the sample, it looks like everything was correct. It looks like the training was good. But the reason why we are rejecting it, statistically speaking, is because the sample size is too small to warrant a rejection of the null hypothesis. That is why we had no choice. We cannot reject the null hypothesis because we have a too small sample size. Let me explain that practically for you. Let's assume that EcoBank sent 5 people for the workshop. EcoBank, because the training, all of them have reduced their complaints. EcoBank cannot generalize and say that that workshop was good. EcoBank cannot say that because what? Only 5 people have cut down their complaint. What EcoBank has to do is to send another 5 people and another 5 people and another 5 people and another 5 people. In this case, what is EcoBank doing to the sample?
Increasing the sample size.
EcoBank is increasing the sample part. Okay, after EcoBank has sent enough people, and what do we call enough? 30. A sample size is said to be large when the data is 30 and above. So when EcoBank has sent enough people and all of them are cutting down their complaint, now EcoBank can now conclude, generalize that the workshop was fantastic. And statistics will confirm that as well. In fact, I've done that already. And I can later, I'll test you to go and do that. We'll do this next week, actually, where I increase these same figures. I just increase them from 5 to 30. And when I increase them from 5 to 30, the null hypothesis was rejected. So if your sample size is small, it can lead to bad outcome. That is why when your supervisor tells you should gather more data, you should not complain, because if you don't, it will lead to bad outcome. Eric, you have a question?
Thank you very much for this information. So I want to find, in the context of the question you asked here, it didn't look like there was a population for us to determine if we've had enough sample from. So
you don't need a population to know that you have enough sample. Statisticians have already concluded that when your sample is 30 or more, it's large. And this sample is clearly not 30. Eric, do you get my point?
Yes, please.
It is the point. The point is that it should be 30 or more. It should be highly representative in that context. Okay. So that is why let's assume that you even have an industry where the number of subjects, samples are just 20. Let's say you have the banking industry and the number of banks in the industry, you can't get more than 20. That's even the population of banks. What do? You have to still acknowledge the fact that it's small. So what do? What you can do is that you don't take the data for this year. Take it for last year too. Take it for last 2 years. Take it for last 3 years. What are you doing to the sample now?
Yeah, increasing it.
You're increasing the sample. That's what you got to do. All right. Let's go to the next thing. The next thing is another exercise of hypothesis testing. Yes, Ajuman.
Doc, is it to say that if you don't then have data for the previous years and your total population is less than 30, it is a no-go area for research?
Yeah, for now, it's not. It's not. It is a go area, but it's not generalizable. It's not reliable. It's not generalizable. It's not reliable. I will not put my trust much in it as a predictive force. I cannot use it to make serious prediction. Well, maybe sometimes what you can do is that you have to cut the data into pieces. So if the data is a yearly data, you can make it monthly data. So that for each company, you will have 12 times the data for it. So if the sample is 20, and now for each one, you have monthly data. Now you multiply 20 by 12. So you now get 240, observations just to increase the sample. Or you can make it, instead of monthly data, even weekly data. That will increase the size, or daily data. So that is one way you can augment, raise, increase the size. Yeah, Masa, you got it.
I'm just looking at the case. I'm just looking at a case where probably it's the first time and you want a baseline in terms of record, so that in your subsequent trainings, then you can match what you have to the new one. You still insist because the population, in this case, I'm not even talking about sample, but the population itself is less than 30.
Yeah.
It's still not too okay to
you use the word baseline. So you want to use it as a baseline for what?
I mean, for subsequent trainings and research that you do.
Okay, when you say you want to use it as a baseline, let me understand. You are using the word for subsequent training. Are you still talking about this complaint?
Yeah, so for this complaint,
So let me tell you what you should do. In case of this complaint, let's say this is your first time. What you got to do is that go to the company. You tell the company, can you tell me other people you have trained? Can you tell me other people you have trained? Now, if it is the company themselves who want to know whether they have done well, if that's what you mean, is that what you mean?
Yes, that's what I mean.
Okay. So the company themselves, this is the first time they are training people, and they've done well by training 5 people. In this case, the company can never use this as a yardstick. Never, ever, ever. You have to wait for a while. Do you know why people want to invest in companies that have stood the test of times? Because you want the person, the company, to go through the experience. What if the next group come and they all fall out? So you can't use it as a basis for anything. Out. So sometimes you just smile at it and move on. Boss, let me tell you, Man United, Arsenal, they even had so many games in which they were winning. And it looks like they were going to win the league. Even with that data, they could not use it as a stepping stone to detect whether they can win. Even if they did, it was not materialized. So you need a long history of things to be able to make a generalization, because you're going to eventually use the data for predictive purpose. You can't predict well without past records. You can't forecast unless you want to create a simulation. And even in a simulation, you got to bootstrap. Okay, you get a picture.
I do. So what in fact you're saying is that the result, even though it looks positive, it could probably be
It means nothing for now. Yes. Even though it's positive, it means nothing. Take it from me, it means nothing for now. Do it 2, 3, 4 more times. Masa,
Okay.
But in any case, if you could train 5, why didn't you train 10? Why not 30?
No, so we are making a case to say the total population is 5. It's not like we selected a few, but the total population in terms of sales people are 5.
Which is fantastic, which is a more reason why you cannot also generalize.
I'm looking at it in a case where, like you said, this is the first time this training has been done. We want to do the training again, maybe the next year or the next 2 months.
Okay.
And we are now assessing the vendor to see whether the training that was given the previous time was impactful, to therefore conclude whether we can rehire this same vendor.
It was impactful for this purpose alone, not for the next purpose.
If it's impactful, can it then not be the basis to say that then let's rehire the same person or the same vendor?
No, because you don't know the other groups of people. You have not tested it through time. Time matters.
All right, thank you.
All right, let's move on. So that's it. Time matters. You see, life is not a straight line. No. The world that we are living in, it is not a straight line. You can't use. There are so many uncertainties in the world, so many uncertainties. Even when there are things you have repeated and over and over and over, it's still not certain the next one. How much more even things that you haven't repeated over time? The reason why people are employed based on experience, that is it. They are not employed because he has had first class. They were employing you because of your experience. Okay? Your first class is a one time, but your experience is over time. Okay, do you get a picture? Okay.
Yes.
All right, okay. Now let's go to the last one for today, and that is Mann Whitney. So it's the same as this one. Okay, the only thing is that we are assuming, what we are going to do is this one. We are assuming that the data set is not normally distributed. The previous one, which was a pair t-test, the data was normally distributed. Okay, but this one, we are assuming that the data set is not normally distributed. Now, when we say it's not normally distributed, what I mean is that the data set is skewed. That's what I mean. Okay. I simply mean that the data set is skewed. Now, because it's skewed, you cannot use any of the parametric tests. You got to use one of the non-parametric tests. But we are also assuming that the data is independent. The previous one, it was paired, meaning it was dependent. But the one we are going to look at, the data is independent. So are we going to deal with the mean or the median? In this one we are going to use. You can tell me. Are we going to deal with the mean or the median? Mean or median? Selassie?
Median.
Thank you. So median means that we are dealing with M1, M2. M1, M2. Let's take this story so that you can use it to demonstrate the point. It is also two samples, but just that the sample is independent and the data is not normal. Here's a story. Kolebu Teaching Hospital is undertaking a clinical trial. The trial is designed to check the effectiveness of a new drug they have brought into the market. The one who brought the drug believes that that drug can reduce asthmatic attacks in children. So they decided to take 5 people. Okay, these are the 5 people. They decided to take 5 people, and then they gave these 5 people placebo. I'll come back to that. Then they took another 5 people, and then they gave them the new drug they have created. The question is this: is there a difference in the asthmatic attacks, the number of asthmatic attacks, between those who took the new drug compared to those who took the placebo? You want to check. You believe that the new drug is so powerful that it should reduce the asthmatic attack. But you also had a placebo. Or let me quickly ask, which of you can explain what a placebo is? What is a placebo? This one is not toil. You either know or you don't know. You know or you don't know. Ajwa.
So it's like a make-believe. It's quite psychological.
So if a 6-year-old tells you this is what you tell the person. Because you know you are saying it quickly. Eh? You have to explain. Yes, I am. Eric, what is a placebo?
Okay, so the placebo, I think a control sample, they are giving something that is not exactly what is being tested. So if we are testing the strength of a particular drug, we give a drug that may not contain maybe all the elements, just as a control for the control population, and we see the results.
You can explain things. Do you guys all understand? So that I move on. Because the way you are saying it there, I should assume, do you all understand? Because the way I would have explained, yes, Mami, tell them. AC. Or your hand went to just raise the thing. Yes, I'm Wanima. Pastor, can you unmute?
Yes, sir. So it's a drug that's given to, which has no chemical effect on the body, given to patients think that he's been given a drug to have that psychological effect, that something's working on his body to cure him or her of whatever ailments he has.
Okay, so first of all, it's not a drug. It's not a drug. You people are defining it as if it's a drug. It can be anything. Do you know when you get to the hospital and you see the doctor garbed in a white overall with a stethoscope in his ears, that aura of professionalism beseeching the medical doctor who is garbed in a white overall with a stethoscope around his neck, the aura is said to have a catalytic ventilation effect on the patient. That is a placebo. It is just like the psychic paraphernalia in the voodoo shrine. Have you ever been to the voodoo shrine? If you go there and you see mathematics books, economics books, management science books, project management, would you actually believe that this man is a proper juju man? Can he truly kill your enemy for you? No, because the aura is not great. It doesn't have a catalytic ventilation effect on you, the voodooist. That paraphernalia are not good. So my grandmother can go to the hospital and see the doctor. Just by seeing the doctor, all his troubles are over. That is also placebo. It gives you that positive catharsis. Opele, you get a grammar, eh? Now, when you go to this psychological effect that you are talking about.
Thank you, Doc.
So it can be a drug. It can also not be a drug. It can be a sugar pill. It can be a water pill. My grandmother will say that she's well, not because she has been given anything to swallow, but because of the environment. In fact, somebody told me that mouth-watering food can even be a placebo. By the way, which of you is aware of nocebo? Is anybody aware of nocebo? Nobody has ever been aware of that one whenever I mention it. Go and find out the meaning of nocebo. Not placebo, nocebo. If you believe that you are going to pass, you pass. But if you believe you are going to fail, you have already failed. That is nocebo. Nocebo. By the way, go and watch the movie known as Nocebo. Hey. Ajimai.
It's more like the opposite to the placebo. So where the patient thinks that what he's doing is going to have a negative effect, and it's more or less ends up having a negative effect.
Yes,
or worsen
with
his
nocebo.
recommendation.
You know, a lot of people in your class have nocebo. They do. Anyway, so now let's check whether this new drug is good. Okay, that's what we are going to check. Look at the data. The first thing you want to write down, is you want to note this down. Put the data together and arrange them in ascending order. That's the first thing. Put the data together and arrange them in an ascending order. Put the data together and arrange them in an ascending order. Okay. So if you arrange this data in an ascending order, don't forget the group they belong to. Don't forget the group they belong to. Which number will come first? You can tell me. If you arrange this data in an ascending order, Marilyn.
1.
Which group is that?
It's under the new drug.
Okay, so 1, new drug. I think your network is not good. Let's go to the next person. What is the next number? Alimatu.
Set 2.
Which group?
New drug.
Next one. Dennis. Betty.
3, new drug.
Thank you. Agnes. Next one.
Set 4. Placebo.
That's wrong. Next one. Gifty.
Hey, 4 is new drug, so but they are both.
Please mute yourself. Now waiting at the end of that. Sandra.
Hello, sir.
4 for both.
4 for both. I like that word. Okay, it's supposed to be both. So it's 4 and 4. Next one, Elliot.
The 5 for placebo.
5 for placebo. Next one, Georgette.
6 for both.
6 for both. Very good. So 6, 6. Guys, pay attention here. Next one, Amma.
7 for placebo.
7 for placebo. Last one.
12 for placebo.
12 for placebo.
Okay. I hope you're all doing it as I'm doing it. So we've organized the data in an ascending order, considering which group they belong to. That's the first step. Second step, move along with me. Pay attention. This is the most difficult part. If you can crack this part, you are done. Rank the data Yes, Valentina, what's your question? Asante, what's your question? Ali, what's your question?
Doc, please, I don't understand why you arranged it differently, because I did it in a horizontal form, just like the table, and then I arranged it. But it looks like you arranged it differently in a vertical order, leaving space for placebo. Is there any special reason to that?
Just so that you see that it is going in an ascending order. And in the vertical way, you know, so that you see that it is climbing downwards. If you do it in a horizontal way and you understand, no problem. There's no problem.
Okay.
If your eye see things horizontally and my eye see things vertically, no problem. Okay. So the next is to rank the numbers. Rank the numbers. But there's a big but. If there is a tie, use the average. Use the average rank for the numbers. If there's a tie, use the average rank for the numbers. Guys, some of you will be lost here if you get distracted for even just a second. So follow me. In order for you not to get lost too much, I'm going to give you a quick example before I come to this one. Follow me, please. Follow me. So let's say that we have group A and then group B. And these are the numbers under group A. I'm arranging it in order quickly. The first is 4, then 4, then 6, 6, 6, 6, and then 7, and then 8. So there you have it. I'm going to do rank for A. And then I'm also going to do rank for B. The first one will be given a rank of 1. Which number is that? Follow me. The first will be given a rank of 1. Which number is that? Valentina.
6.
Which number is that?
6.
That's wrong. The first will be given a rank of 1. Which number is that?
Can you go over?
4.
4. However, the 4 is a tie. And so because it's a tie, the second would have been given a rank of what? The second 4 would have been given a rank of what? Sandra.
So please, can you go over how you arrange and started with the 4?
I've not started. Yeah, I've not started. Don't get confused. You see, I told you get confused. You're already getting confused before the confusion comes. I said I'm about to rank them. The lowest will be given a rank of 1. The next lower will be given a rank of 2. The next lower will be given a rank of, and then keep going. And I'm asking here, which number will be given a rank of 1? Abeta.
4.
And the next number that will be given a rank of 1 is what?
4.
Yes. So there are 2 numbers that would have been given a rank of 1. But you can't give both of them a rank of 1, 1. It's wrong. The ranking must be given as 1, 2, 3, 4, nothing. So ideally, this is how we would have done the ranking. This should be given a rank of 1. And the second number, 4, should also be given a rank of 1. But you can't do that. And so what you do is that you add the ranks together and take the average of the rank. I want to repeat, write it down. You add the ranks together and share the answer for both of them. You add, I say write it, you are not writing. You add the ranks together and share for both numbers. So if you add the rank of 1 and 2, and then you take the average, average is 2. What do you get? Betty?
1.5.
1.5. So what you will do is that you will share this 1.5 to this guy. Don't forget where it belongs. And then share this 1.5 also to this guy. Hope you all get it so far. I'm moving on. If you don't get it, let me know before I move on, because when I move on, it will be confusing to you first time. So the first thing you do is that you ensure that the ranks are given. There is no tie. There is no 1, 1. There's no 2, 2. No, it's 1, 2. But because the numbers themselves are tied, you have to share the rank, the average of the ranks to them. Okay. Now, where did we end? We ended at number 2. So the next rank is what number? The next rank is what number? Rank. Elliot?
3.
3. But unfortunately, that one also brings about ties. So you have to find the average of which rank? Who can tell me? Which ranks do you now have to find the average? Because of the tie. Agnes?
3 and 4.
No, that's wrong. Frida?
3, 4, 5.
Okay, I didn't hear her complete it. Selassie?
Yeah, 3, 4, 5, and 6.
Hello.
3,
so you have to find the average
4, 5,
3
and 6.
plus 4 plus 5 plus 6. What do you get? Average.
3, 4, 3, 5, and 6.
What do you get? Marilyn?
4.5.
What?
4.5.
4.5. Is that what you get?
Yes, please.
Okay.
4.5.
So you get 4.5, and you have to share that to all of the 4 numbers, the 6666. So you give this one 4.5, you give this one 4.5, you give this one 4.5, and you give this one 4.5. Don't forget where you ended. So the next rank is rank what? Who can tell us? Agnes?
7 and 8.
No. The next rank is rank what? Amma?
7.
7. That is it. And that is for which number? Amma? That 7th rank is for which number? Jacqueline?
7.
7. So you give the number here. The next rank is which rank? 8. That 8 is for which number, Kelvin? That 8 is for which number? Jacqueline?
8.
8. So you put it here. That is how you do the ranking. Remember, I told you that some of you get a little bit confused, and it has happened. It's okay. Okay. When you go through it, you get it. Now, let's go back to our table now. We're about to do the ranking for our placebo and new drug. Okay. So I'm about to create RP here for the placebo, and then the rank of N for the new drug. Okay. So, guys, what I'm about to do is I will ask you, and then once you tell me the group they belong to. Just calculate the ranks and just tell me the rank. Okay. So the first number will be given a rank of what? Who can tell me? The first number will be given a rank of what? Erica.
1.
Okay. Which group is that?
The new drug.
Okay, good. 1. The second will be given a rank of what? Salasi.
2.
Which group?
New drug.
The next will be given a rank of what? Lisbeth.
3.
Group.
New drug.
The next will be given a rank of what? Mariam.
Four and 5 for placebo and new drug.
Wrong. The next will be given a rank of what? Agnes.
The 4.5.
You don't just say 4.5. Come on, we are sharing. So you have to mention it well.
It's 4.5 plus
4.5 for placebo and
You don't have to
4.5
say
for new drug.
4.5. Just say 4.5, 4.5. That's all I need. See, we are sharing. Okay. Because we are sharing, once you say 4.5, you have to say 4.5, 4.5. Okay. All right. The next will be given a rank of what? Favor. Ajaman.
6.
6. Very good. Which group?
Placebo.
Very good. There's a reason why I asked which group. The next will be given a rank of what? Amwanima.
7.5, 7.5.
Good. 7.5, 7.5. You guys are getting it now. The next will be given a rank of what? Eric.
9.
Which group?
Placebo.
Good. The next will be given a rank of what?
10.
I mean, I heard that. I mean, your calculator with you. Okay. All right. So the next will be given a final rank of 10. That is how you do the ranking. Ranking is the most difficult part of this analysis. Once you can crack that, you're good to go. The most important thing you should remember in the ranking is that when there's a tie, the tie is for the rank. You're only finding the average of the rank and share it for the ties. But don't forget where you ended and continue from there. Because sometimes if you go and share 4.5, 4.5, then you would think that the next one is 5. But it's not 5, it's 6. So take note of that. All right. Once you are done, the next thing to do, and by the way, the most difficult part has been done. The next thing is to add the ranks together. So find your R1 and then your R2. The R1 is the total of the rank in the first group. And the R2 is the total of the rank in the second group. What is R1 now? Yes, Mariam. Betty.
37.
R2 is what? Betty.
18.
18, good. Guys, this is where when you don't understand why the person got a 37 and 18, you have to take your calculator and punch it later all by yourself. Okay. The next thing is to know these two commandments. The commandment I'm about to give you will always help you to know you're on the right track. That's all. So here's the first commandment. I will write it and then delete it. The commandment says that when you sum the two ranks, they should be equal to n times n into brackets n plus 1 all divided by 2. So you write it down, write it. If we have to write it. So the rule says that, the commandment says that there are two commandments for this. This is the first one. The commandment says that if you add the two ranks and they are equal to the n into bracket n plus 1 over 2, then whatever you have done so far is correct. Okay, so let's add the two ranks. When you add the 37 plus the 18, what do you get? 37 plus 18, Betty.
55.
55. Okay. Somebody will later come and ask me, how did I get a 55? So let me put it here. 37 plus 18. The next is to check whether that is equal to n. N is a total sample. Total sample. What is the total sample here?
10.
10. So you write 10 into bracket 10 plus 1 all divided by 2. What would that give you? 10
110 over 2.
110 over 2 is what?
55.
55. So they are balanced. So at this stage, it means that you are done. You can even slap the invigilator. No, don't do that. Because you are sorted. Now that you have balanced it, you can go and calculate your test statistic. I'm deleting this so that I can calculate my test statistic. So how do you calculate a test statistic? It's a beautiful formula. This is it. There are two of them. You just have to do the two and choose one. U1 and then U2. Remember, this is Mann Whitney U statistic. It is given by R1 minus N1 into brackets N1 plus 1 over 2. And the other one is R2 minus N2 into brackets N2 plus 1 also over 2. This is simple. What is R1? It is 37. So let's put that here, 37. What is N1? Who can tell us? What is N1? Ajiman.
Look, mine is a question. You were giving two commandments, but I think you ended at
yes,
one.
I always give the next commandment after calculating the U, because then it will make sense.
Okay, all right, thank you.
What is N1, Betty?
5.
5. So you put a 5 here, and this is 5, and this is plus 1 divided by 2. Okay. So what is the total of this in number here? Erica. What is the total of the n1 into bracket n1 plus 1 all over 2? Erica.
22.
22 is wrong. I mean, what is the number here? She's gone ahead of. I'm at.
So it's 22. So 37 minus 5.
No, I didn't say 37 minus. I wanted that 15, first of all. Okay, so you were calculating faster. So this will be 15 before the 37 minus 15 gives you the 22. This will also be 15. So the 18 minus the 15 will give you 3. So our U statistic, the first one is 22, the second one is 3. You always choose the second one. Sorry, you always choose the smaller one. Write it somewhere. Always choose the smaller U. Therefore, our final U statistic is equal to 3. We are done. Now let's go to commandment number 2. Commandment number 2 says, just so you know you are correct, it always says that your U1 plus your U2 must always be equal to your N1 times your N2. Please verify that. Verify that. And let me know whether that balances. U1 is 22. U2 is 3. N1 is 25. N2 is 12. Sorry, N1 is 5. N2 is 5. Yes, Betty.
Yes, Prof.
Mm-hmm.
So it's 22 plus 3 is equal to 5 times 5, which is 25 is equal to 25.
Good. So you can see that the commandment also balances. So at this stage, you know you're on the right track. You can go and swim in the sea. The most important thing is that you know your value of the T statistic. So sorry, the U statistic. This is the test statistic. Please don't worry, this stage, for this one, I will not bore you to find the p-value and the alpha. We are only left to finding one last thing for today, and that is the critical value. Remember, you always need the statistic and the critical value. How do you find the critical value? Well, look at the top here. The critical value, which is called U critical, is given by U subscript alpha, comma N1, comma N2. Alpha, comma N1, comma N2. What is the value of alpha, since we were not given alpha here? What is the value of alpha? Since we're not given alpha, what do you think is the value of alpha? Hey, unique.
5%.
Very good. So it means that U is 0.05. What is the value of N1? Erica. Ali.
5.
Say 5.
And what is the value of N2, Ajiman? Okay. So
I'm sorry, I'm lost. So
for both of them,
maybe
just lower your hand so that I know that you're not with us. So now that we've gotten.
Sorry, not that I'm not with you. I'm lost. So I wanted to ask a question. That's why my hand is up. I'm sorry.
Okay, ask your question.
I missed the formula for the U statistics. Just wanted to be sure because I'm wondering how we got
It's on the far left here. And again, it's in your slides, it's in the video. Use underscore subscript alpha n1, comma n2. Okay, so ladies and gentlemen, we are going to find this from the table. Remember, critical values, we always find them from the table. So we just need to know that we are looking for 0.05, then 5, then 5. Okay, so let's go to the table. This is the Mann Whitney U table. If you have checked it before coming, you would have known that this is it. This is the Mann Whitney U table. In this table, there's something you got to know. The table is in two parts. We have the two-tail part, and we also have the one-tail part. I am showing on your screen the two-tail part. I want to scroll down, you will see the one-tail part there. Now, in this question, did we formulate the hypothesis? I think we didn't. Well, let me just take you back. Guys, look at the sentence here. It says, is there a difference in the number of episodes of shortness of breath? So that tells you that the symbol for the hypothesis is what? You can tell me. That tells you that the symbol for the hypothesis, what is that symbol? I mean, even if you don't know anything today, you should get that symbol. Valentina Peterson.
Not equal to.
Okay, so this is how you write your hypothesis. You write M1, M2, okay. M1, M2, then M1, M2 again. Then you bring your not equal to in between it, and the opposite is equal to. Which one is a null hypothesis, top or down? Which one is a null hypothesis? Erica?
Down.
Down. So down is a null, and then the top is alternative. What is a null saying? The null is saying that the number of asthmatic attack, the difference, the median number of asthmatic attacks between those taking placebo is the same as those taking the new drug. In other words, this one is also saying that the new drug is useless. That's what it's saying, actually. Go and analyze it and see. So it's saying that the new drug is bogus. So keep that in mind. So is this a one-tail or two-tail? Is this a one-tail or two-tail? Unique.
It's a two-tail.
It's a two-tail. So when we go to our table, let's go to our table. Okay. When you go to our table, you have to select the Mann Whitney and remember to use the two-tail. So this is the two-tail that you see on your screen. Okay, so watch something. First, it comes with N1 and N2. This is our N1. The N1 are the top numbers. The N1 are the top numbers. Take note, please. The N2, okay, the N2 are here. Look at them there. The N2 are here. They are on the far left. The N1 are those numbers on the top. The N2 are those numbers on the far left. According to the formula says that U subscript 0.05, comma, N1 is 5, comma, N2 is 5. So locate 5 for the N1, then locate 5 for the N2. Don't forget we are using 0.05. Where they will meet is your answer. Have you found it? Have you found where they met? Have you found a number there? Georgette, what's your number?
The number is 2.
The number is 2. That's it. So when you match this 5, okay, when you match this 5 against this 5, they will meet at the number 2. So that means that your U statistic, sorry, the U critical is 2. You remember the U statistic? If you can remember, we found our U statistic to be 3. Then the U critical is 2. We are ready to decide and conclude. Write this down. This is a decision rule. It's just the opposite of the previous one. It says that reject the null hypothesis. Reject the null hypothesis if the U calculated is less than or equal to the U tabulated. Finish. Reject the null hypothesis if the U calculated is less than or equal to the U tabulated. Our U calculated is 3. Our U tabulated is 2. Should we reject the null or we don't reject the null? Onkasaya, this is your time. Should we reject the null or we don't reject the null? Gabriel.
We don't reject the null.
Why?
Because the U calculated is greater than the U tabulated.
Good. So what is your conclusion, Gabriel? How will you conclude now? Who can conclude? What is our conclusion? Since we are not rejecting the null, what should we now conclude? I just need some great one to end it all. What is our conclusion? Sarah.
Hello, sir. So since the U calculated of 3 is not less than the U tabulated of 2, we do not reject the null hypothesis at the 5% level of significance and conclude that the drag is useless.
That's good. Hey, was it all coming from your head?
Yes, please.
Hey, then you are good, Papa. That's good.
Okay.
That's really good. I'm telling you, you're really good. You are wonderful. No wonder you can sit at home and then join lectures. Yes, ladies and gentlemen, that conclusion she gave was a powerful one. So the new drag is not good. Once again, the sample size was small. That is why the conclusion happened like that. But in any case, that brings us to the end of the entire caboodle. Okay. Everything that we have done is in the slide. Go through it one more time. It will all make sense to you. Okay. Ladies and gentlemen, I have typed how to do this in R. You have downloaded the R and the R Studio. Go through it. Use the command I've given you to go through it. That's what we are going to do next time. Try your hands on the example I've given you. It's a practice example. Try your hands on it. And then when we meet next time, we'll do it. So when we meet next time, we're going to do 2 things. We'll look at ANOVA, and then we'll use the R software to understand everything that we have been doing so far. So please, if you have not downloaded the R software and the R Studio, please download it before we meet next time. Wonderful.